Germany is in the midst of a technological breakthrough. The German mechanical engineering sector has spurred industrial progress globally for years. The term Industry 4.0 thereby stands for the vision of a fourth industrial revolution. But is it really a revolution? Small and medium-sized businesses prefer the term evolution, as technical innovations arise every day in Germany. Innovations are the heartbeat of the German machine and plant construction industry, and Industry 4.0 is already commonplace in production. But let's start at the beginning. Industry 4.0 stands for a paradigm shift. In this demonstration plant of Bosch Rexroth, the final product controls the machines by which it is produced. The key is tagged with an RFID chip, a kind of radio transmitting label wherein all its properties are stored. It now instructs each machine what to do. That's why our key gets a yellow mark and not a blue one, as for example the key behind it. What looks simple at first glance requires highly complex controls and sensors that significantly affect the entire production. In the Daimler-Benz plant in Rastatt, the dimension becomes clear. Here, every vehicle body is RFID tagged right from the beginning. Similarly, all details of the vehicle are stored on it, from the wheel hub to the equipment. Via transponders, the RFID data are queried and new data returned. The RFID tag is almost constantly updated with current information, indicating to what extent the vehicle has already been completed and what is still missing. The insignificant-looking tag has a lasting effect on the complex interaction of the gigantic production structure. It instructs the robot in the broadest sense what to do next. In an environment of 1,500 interacting automation units, where 1,200 vehicles roll off the production line every day, the significance of the information in the RFID tag will clearly be comprehensible. It enables and controls a highly productive process. But first of all, technical hardware and software solutions had to be found before everything was able to be running smoothly. The requirement of the customer in the workshop was a wide reader range of up to 1 meter. This is why we applied the UHF technology for the first time. However, the radio waves are greatly reflected in the highly metallic environment, leading to an impairment of the read results. We could solve this problem by developing special algorithms and integrating them into the reader devices. But no production can function ideally when the material flow is not absolutely free from error and wrong parts creep in. Fully automatic logistics systems with driverless transport systems equipped with sensor technology provided by Balluff provide the finishing touches here. The integrated sensors check each box and its contents for accuracy. Again, RFID technology is the basis. In automated production, people and machines are responsible for materials replenishment. As the components sometimes are quite similar, precise control is essential. So, only boxes with the right parts or components arrive at the destination, otherwise they will be stopped and a warning signal given. It's clear that an incorrectly assembled part in a finished product is a bigger and more expensive problem than ensuring correct assembly during production.
The
requirements on sensor technology, especially in the context of Industry 4.0, are that we need much more detailed information from the working environment. We must also be able to track goods, as here in this plant. And we need to combine sensor principles that record, for example, temperature or distances. At Phoenix Contact, there are RFID chips invisibly integrated that allow a flexible production of one-off items. This ensures that at hybrid working places where humans and machines collaborate, there are always appropriate product-specific instructions. Combined with intelligent control systems, complex production systems can easily be set up and configured by on-site operator teams and needn't be programmed. With these technologies, it's possible to control manufacturing processes in a situation-oriented manner and adjust them when necessary. The interconnection of the machines in the factory's network allows smooth communication with various IT applications in the company, meaning that production cells, such as labeling processes, can be supplied with the required information in an audit-proof manner at runtime, for example, geometry and process data. This enables the production cells to individually adapt to the next product. Digital product models are used to prepare vision systems and robots during operation for the next task in hand. Industry 4.0 helps to maximize productivity with the maximum flexibility of production without overstressing staff members. In realizing individual customized mass production, automated production plants have become more complex. The challenge is to enable operators to configure such systems instead of needing experts who program them. It's also essential that the control and IT systems display faults and malfunction information clearly enough for the operator to quickly and efficiently locate and eliminate the cause. The interaction of hardware, software and communication plays an increasingly important role in the machine and plant construction industry. Technology that functions precisely with programmed intelligence and flawless communication in a production system can be characterized by the term Industry 4.0. In this context, intelligence means that, to a certain extent, machines make decisions, but these are monitored by people who can reverse them at any time. Principally, the final decision maker remains the operator, but secure and stable communications are an absolutely essential precondition. For example, this tunnel boring machine from MTS Perforator. It works underground and independently tunnels through the ground. The design engineers understood that a machine meters under the surface is difficult to maintain. It's why they relied on not only high-quality components, but also on robust and resilient control and communication technology provided by Eaton. These smart devices allow a detailed data access to the control elements from anywhere in the world, so that in the case of malfunction, remote diagnostics can quickly be made and a remedy found. This ensures a high facility availability for end users. It also makes it possible to protect the machine globally from manipulation and prevent danger to users and equipment. That we can log on to this machine from my office workplace here means we have one communication partner here, and on the machine the corresponding communication partner is installed. After starting both programs, I can access this machine over the internet, allowing me to make a diagnosis. I can find out where the defective parts are, which ones have to be replaced. Using this information, service personnel can go directly to the machine with the necessary spare parts, or we can advise the customer on site from here, which may allow them to solve problems directly and find a remedy. In industrial processes, secure data lines are becoming increasingly important. Particularly extreme environments, such as heat, cold, dirt, or other sources of interference, present technical challenges. Corrupt data or an interrupted communication process could have fatal consequences. The impact a disturbed wireless LAN system could have is evident at the HHLA container terminal Altenwerder in the port of Hamburg. Here, automated guided vehicle systems already control and organize themselves over a wireless network. Heavy containers change their locations independently, as if by magic. They unload and load ships around the clock. Without a fail-safe and protected industrial wireless LAN technology, the self-propelled container transporters would be difficult to control. For industrial wireless LAN, there are always two aspects to consider: the software aspect, which enables the real-time transmission of data packets, such as Profinet, and the hardware aspect, which ensures that the devices can be used outdoors, for example, under very wide temperature ranges, and the devices are particularly robust, so they can also be used for mobile applications. Access to the port of Altenwerder is, for good reason, restricted, but the collaboration between human and machine is becoming increasingly important. For example, the folding press stops directly a hand moves inside the danger zone, governed by a camera system using LEDs and software image analysis. In more complex facilities too, people need to be protected. With its 3 cameras, the safety eye system from Pilz monitors in 3 dimensions. Thanks to intelligent software, an operator can easily determine shelters around the machines and facilities. When the operator enters the defined safety zone, according to the programming, the facility will be stopped immediately. Restarting the machine can only happen after the operator has left the safety zone and confirmed his departure. In combination with controls, intelligent sensor technology allows new degrees of freedom for the implementation of dynamic processes, allowing working areas to be created where humans and robots can interact optimally, and the safety of the operator remains guaranteed at all times. The Vago company operates several state-of-the-art injection molding plants at various national and international locations. Billions of plastic parts are produced here annually. Worldwide, all production sites and all production machines are interconnected. Authorized employees of the company are able at any time to globally query information about all the products, their production output, or about machines of any type and production method in real time. For example, the current order status of each machine and respective quality grade, and the level of efficiency. Worldwide interconnected IT systems, and in particular the integration of production systems, involves a significant increase in productivity as well as special dangers, for example, virus attacks. Measures for protecting the system, summarized by the term security, are a continuous task. The effort required is often significantly underestimated. The particular challenge for us as a company is not only to analyze our processes, but also to ensure that our processes can only be influenced by well-qualified personnel. We achieve this by securing our entire machinery and equipment with RFID technology, and don't use password levels anymore. Passwords can be learnt by anyone. RFID transponders are only worn once by each employee. Software, hardware and communication are the triad of Industry 4.0. The entire production chain is controlled and documented, with the highest quality and productivity. But when will Industry 4.0 be broadly implemented in manufacturing industry? In my opinion, Industry 4.0 will become reality when the meaning and purpose of Industry 4.0 is no longer discussed, but it becomes a matter of course for flexible collaboration between ultra-modern factories and value-added networks, using the latest information and automation technologies. Perhaps then we will realize in retrospect that a revolution has taken place.